So this is just a video explaining the resource development and the assessment of this topic. The current topic is linkages and the loci associated with the linkages. So I'll just go back there a small bit to the anticipated difficulties that we've discussed so far with regards to the topic. And we can see here, just to rush over it, a lot of the anticipated difficulties might be due to visualization and the complexity of links and linkages in questions or problems that you might be talking about within the topic. So a couple of the resources that I've looked at here are a 3D model and GeoGebra models, um, just to show how some linkages and questions might work. Both of these are my own original work, and I've included the part files and assemblies here. The assembly itself will include a motion study showing how all the linkages and everything works. So if I just click into this link here, that'll open up there, and you can see that I have all the part files here. I'm not going to open them there at the moment, but if I just click into this video, hopefully it'll work. Yeah, so it's just a SolidWorks video showing how the linkage in question works. So you can show that to a class, and if it's a linkage in a question. And the great thing about this is you can actually edit the individual parts themselves. They've been designed with intent, so you can change the length of the linkage or the links and add more or subtract some, and it'll still work, hopefully. And obviously you'll need to know how SolidWorks works to use these, but there's one resource anyway. The other one is GeoGebra. Now GeoGebra is great because you can actually plot the link or the loci of the different points in a linkage in a question. So again, if you know how to use it, you can use it to simulate a question that you have. So just another video here to show a linkage that's working. And we have it here, it's just 20 seconds. It shows two linkages, a crank and a slider. And once you show the animation, it'll actually plot the loci of each point and the slider in a different color. So it's a little bit, the frames are a little bit rough there, but hopefully you can get a better video. So then we have the assessment of the topic. It's just a short and sweet question, just showing a person cycling is an everyday example of a crank and rocker linkage. So then you have the question here on the right with the dimensions. Now it only has 3 dimensions in it. Just the radius of the crank and then the height here between the crank and the hip joint. So if A will represent the hip there on the person. And then one of the, say, the shins, the shin of the leg. Now, if a student understands a leg or how legs work, they can take that 140 millimeters there and assume that from here to B is also 140 millimeters. So then they just need to bridge that gap there between C and A, and that there will be the same. And then all they have to do is plot the locus of the points B and C for one revolution of the sprocket of the bike. And then we continue on here to the rationale and the solution. We can see here now there's actually only one loci that they have to plot out, and they will actually recognize that if they understand how the linkages work. Because if you go back to the question here, these 2 points, they're on the same crank, and they're all, like, both linkages are the same length. So a student that doesn't know what's going on might assume that they'll have 2 different loci to plot out, but a student that does know what's going on will recognize that there's actually only one that they have to plot out. So it's only one set of dividing up the circle and then creating their linkages there to plot out their loci. Okay, so I've gone a bit over here, so I'm going to stop recording.